So I've been asked by several people to do some example problems of simplifying rational expressions. And here's kind of a straightforward one that I think will help us understand probably the big idea. So the goal is to simplify this by factoring or pulling things out or getting things into like terms. And then we also have to tell our end user what the denominator cannot be, what value of x makes the denominator 0. So when I look at this top part, what I see is I see that there is this 10x squared plus 40x, and I know both 10 and 40 have 10 in them, and I see that there's an x in both, so I'm going to go ahead and factor out a 10 from the top and the bottom. So I'm going to take a 10 out and an x out. And then what am I left with? Well, I'm left with an x. I'm just reverse distributing. And then I'm left with plus 4. And then the denominator stays the same. It's x plus 4 still. Well, now I can start to see, oh my gosh, I've got this x plus 4 on the numerator and this x plus 4 on the denominator. So I'm going to go ahead and I'm going to cancel them out. And so the simplest form of this expression is 10 times x, or 10x. But we've got to tell our reader what cannot be on the denominator, because we're scared that if this denominator is 0, that we'll have an undefined function. So which value of x makes that 0? Well, I'm going to do kind of an aside problem off to the side here and say, when is x plus 4 equal to 0? And say, well, we know we can't have that. So this is just an algebra 1 problem. I'm going to subtract 4 from both sides, subtract 4, and I'm left with x equals negative 4. So in our main problem, I'm going to come back, and I'm going to say, well, 10x is the simplified version. 10x is the simplified version of the of this original expression, but x, let's get our pen there, but x cannot be negative 4. So this is, as a whole, our final answer, 10x, but x can't be equal to 4. Let's move on to something a little more challenging that isn't able to simplify quite as much. So I look at the numerator and I look at the denominator, and 15x and 3 have something in common, and 24 also has something in common. This just takes a little bit of practice. This is something that gets easier as you practice it a little bit more. But I see that there's a 3 that can be factored out of everything. So I'm going to say, oh, hey, there's a 3, and 3 times blank gives me 15x. Well, it's going to be 5x. And then pulling out a 3, I'm left with 1. And then in the denominator, what times 3? 3 times blank gives us 24. Well, that's got to be 8. So I'm going to pull those out. All I've done is said, hey, 15x plus 3 is equivalent to that, and 24 is equivalent to that. Now, I can see on the numerator and the denominator, I've got a 3 being multiplied by stuff, so those 3's are able to be canceled out. What am I left with? I'm left with 5x plus 1 divided by 8. And that's my final answer. Now I go back and I say, what can x not be? Well, can I choose an x that's going to make the denominator 0? Well, if I look back at my original equation, there is no x in the denominator, so we don't have to worry about setting an exclusion for anything. So this is just my final answer, this 5x plus 1 divided by 8. Now, there is one more type of problem that I want to show you, and this is quite common, is to see an expression that could be factored. So I'm going to have to do a little bit of work off to the side in order to make this work. So I like to, whenever I see a quadratic, like x squared minus 11x plus 30, I like to do something off to the side where I am doing the problem on its own. And I'm going to factor this. So I'm going to take x squared minus 11x, and maybe I shouldn't have been so eager to finish that box off. X squared minus 11x plus 30. And I'm going to do my box method. I'm going to put it in a box. I can see x squared, wow, that's really tiny, and 30. And I say, what multiplies to 30 that, what adds up to 30, multiplies to 30 that adds up to negative 11? We can try negative. Well, we need to start with negative numbers. So I'm going to start with negative 1 and negative 30. Well, no, that doesn't add up to negative 11. Negative 2 and negative 15. No, that doesn't multiply to or add up to negative 11. Negative 3 and negative 10. No, that doesn't quite get us to negative 11. That's negative 13, but we're close. Negative 4. 4 doesn't go into this very nicely, but 5 does. Negative 5 and negative 6. Oh, hey, look at that. Negative 5 and negative 6, they multiply to positive 30, and they also add up to negative 11. So I've got my negative 5x. I've got my negative 6x. So I'm going to factor this thing. I've got an x. I've got a negative 6. That's going to be an x, and then a negative 5. And so this in factored form is going to be x minus 6 times x minus 5. Okay, it's a little bit tricky, and this is just prep work for what we're about to do. So I know that my expression x squared minus 11x plus 30 reduces, if I factor it, to x minus 6 times x minus 5. And so what I'm going to do is up here in my original equation, I'm going to replace this x squared minus 11x plus 30 with this x minus 6, x minus 5. I'm going to do that real quick. X minus 6, x minus 5, and then all of that is over the original x minus 6. Oh, look, guess what we got again? We've got the same thing on the top and the same thing on the bottom. I've got an x minus 6 on top, and I've got this x minus 6 here on the denominator, so they're going to get canceled out. What am I left with? I'm left with that x minus 5. Can I exclude anything? Are there any extraneous solutions? Well, yeah, we need to look, what's going to make this denominator 0? And I'm going to do the math out. This is another aside type problem. When is x minus 6 going to be equal to 0? Well, I just do a little bit of algebra 1. When x equals 6. So in my original problem, I have to say that x cannot be 6. And that's a part of my answer. So they're the whole part of the answer. So you've just seen 3 problems that can show you how to simplify rational expressions. I hope this was helpful. Many problems are similar to it, but just know that you might need to factor ahead of time and recognize some patterns in order to complete this successfully.